Hello students, this is Dr. D. Rajalakshmi, Associate Professor in CSE Department of RMD Engineering College. In today's class, we are going to solve all pair shortest path problem. What is all pair shortest path problem? It is a problem of finding shortest paths between every pair of vertices present in a weighted directed graph. The idea behind this problem is we are constructing solution through series of matrices D0, D1, etc. Dn using increasing subsets of vertices allowed as intermediate. That is, in the first step, D0 will be found. D0 is containing the length of the shortest path between every pair of vertices without any intermediate vertices. D1 matrix allows the paths with intermediate vertex 1. D2 is a matrix containing the paths allowing the first two vertices as the intermediate vertices, and so on. In that way, till Dn we are going to find. Here 4 vertices are there. So till D4 we have to find. D4 is going to be the distance matrix. Output of this particular algorithm, Floyd's algorithm, is going to be the distance matrix. For solving all pair shortest path problem, we are using Floyd's algorithm. Now, this is what is the formula we are going to use. That is K, that is the shortest path we are going to find, and this is what is going to be the kth table. Okay, so for finding values of the kth table, K minus table is needed. From the previous table only, the values are going to be found. Shortest paths are going to be found. Okay, so this is what is a diagrammatic representation of this formula. Okay, actually df(i, j) it represents the shortest path, length of the shortest path from ith vertex to jth vertex. So if suppose a direct path is existing in between I and j, then this will be the length of the direct path from I and j. That is d of I, j present in the previous table. That value we are taking. And if suppose if we have any path through an intermediate vertex k, then length of that path is going to be the second value which is available in this formula. That is length of the path from I to k plus length of the path from k to j. Okay, so both the values we are comparing. Minimum value we are taking, that is going to be assigned to d of I, j in the kth table. This will be used for the problem to solve, for solving the problem. Now, this is what is the graph given to us. Okay, so as we have seen already, D0 is the weight matrix. Okay, so if suppose between 1 and 1 there is no edge with any weight, so it is 0. From 1 to 2 we don't have any direct edge, so it is infinity. From 1 to 3 we have an edge and length of that edge is 3, weight of that edge is 3, so it is written as 3 here. From 1 to 4 we don't have any edge, so it is written as infinity. We have an edge from 4 to 1 only, not from 1 to 4. So it is infinity. In that way, the weight matrix is written. And that is what is the D0 matrix. Then from this one, D1 must be found. How to find D1? Using the formula what we have seen already. Okay, so as we have seen already, D1 is containing length of the shortest path that are allowing vertex number 1 as the intermediate vertex. Okay, so for finding this one, first of all, we have to take the 0th row, 0th column of the previous table, and that must be written as it is in this table D1. Okay, and the remaining values must be found using the formula, that is this value. What is the already existing value? That is the length of the path without the intermediate vertex, that is 0. And if suppose if there is a path with intermediate vertex 1, then we will be getting some value, okay, by adding sum of the first row, first column value corresponding to this element, okay. Here it is infinity, here it is 2, 2 plus infinity is infinity. What does it mean? We don't have any path through the vertex number 1 from that is from the second vertex to the second vertex. So that is why we are getting infinity there. So both the values we have to compare, infinity and the 0. 0 is minimum, so we are writing 0 here. Now take this value, second vertex to the third vertex. Length of the direct path between 2 and 3 is infinity. Between 2 and 3. See the graph between 2 to 3, from 2 to 3, we don't have any direct edge. We have an edge from 3 to 2 only, not from 2 to 3. That is why we're getting infinity. But if you take a path through vertex number 1, using vertex number 1 as the intermediate vertex, we have a path from 2 to 3. 2 to 1 and then from 1 to 3. Length of the path is 2 plus 3, 5. Okay. That is what we got here. How to find this one using formula? Na? Already existing value infinity, and take the kth column and kth row value. That is first column, first row value corresponding to this particular element. They are 3 and 2. 2 plus 3, 5. This 5 and already existing value infinity, we have to compare. 5 is minimum. That is why we're writing 5 here. In this way, all the values we have to find. Similar to this one, D2 can be found. Okay. So D2 is the matrix which is using paths that are allowing first 2 vertices as the intermediate vertices. And here D3 is the matrix allowing paths with intermediate vertices 1, 2, and 3. And here D4 is the matrix which is allowing intermediate vertices 1, 2, 3, and 4. Okay, since the graph is containing only 4 vertices, D4 is the resultant matrix, that is distance matrix, output of this particular graph. Okay, now let us solve this problem. We'll solve at least 2 steps of this particular problem. As we have seen already, we have written the D naught. D naught is the weight matrix. That is what is the very first step of this problem. That is, this table D naught or this matrix D naught represents length of the paths without any intermediate vertices. Now we are going to find what is D1 from this table D naught. As we know already, we are going to take the first column and first row of this table. First row value of this table is 0, infinity, 3, and infinity. That is written as it is. Similarly, first column value also we are going to take. Those values are going to be written as it is. So, it is going to be 0, 2, infinity, and then 6. The remaining values must be calculated using the formula. Using the given formula, we have to calculate the remaining values. What is already existing value here? 0. If you take first column value corresponding to this element, the values are 2 and infinity. If you add 2 and infinity, we are getting infinity only. Infinity and 0 we are comparing. 0 is minimum. So we are writing 0 as it is here. And the next value. Next value, what is available in the next value? It is here in the next element. Infinity is already available. And what we can do is, we can take the first row, first column value corresponding to this particular element. It is meeting 3 and 5. 2 plus 3, what is the total we are getting? 5 we are getting. 5 and infinity we have to compare. Which is minimum? 5 is minimum. So we have to write 5 here. In this way, we have to calculate all the values. here already existing values infinity. So if you take first row, first column value corresponding to that, that is also infinity. So we are writing infinity. And then here already existing value is 7. So if you take sum of first column value corresponding to this one, that is also infinity plus infinity. Infinity minimum is 7. So we are writing 7. 0 will be the minimum values. We are writing 0 here. Here also the value is going to be 1. Here it is going to be infinity only. And here already existing value is infinity. Take the first row, first column value of this particular element corresponding to this element, 3 and 6, which is equal to, sum is equal to 9. 9 is minimum when compared with infinity. So we are writing 9 here. And the next value, 0 is already existing. That will be the smaller value. So we are writing as this. So this is what is our D1 value, D1 table. Now we are going to find D2. Okay. So in the case of D2, the matrix D2 is going to consider all the paths without any intermediate vertices, with vertex number 1 as the intermediate vertex, as well as with vertex number 2 as the intermediate vertex. So all the paths are going to be considered here. For finding this one, we have to take second column and second row of the previous table. Previous table is D1. Those values are going to be taken and those values are going to be written as it is here. Infinity, 0, 7, and infinity. And the second row value, 2, 0, 5, and infinity. Okay, so these are the values we have written, and the remaining values, the missing values are there. No, those values must be calculated similar to the previous case using the formula. So what is this 0 and the corresponding second row, second column value corresponding to this particular element is 2, and then infinity. Sum of those two elements is equal to infinity. Compare infinity and 0. 0 is minimum, so we are writing 0 here. And the next element is 3. Okay. And that is the minimum value. So we are writing 3 here. And what about here? Infinity is already available. And if you take second row, second column value corresponding to that, the sum is also infinity. So infinity we are writing as it is. The second row we are writing as it is. And here already existing value is infinity. If you take second row, second column value corresponding to this element, they are 7 and 2. Sum is 9. 9 and infinity we are comparing. 9 is minimum, so we are writing 9 here. And this one is 0 only. That will be the minimum value. And here 1 is the minimum value, so we are writing 1 here. Here 6 is the value minimum, so we are writing that as it is. And here also there is no change. 9 only. This one is 0 only. In that way, we found D2. Similar to this one, D3 can be found. How to find D3? Take the third column and third row of this table and write those values as it is in the third column and third row of the next table, D3. And the remaining elements must be calculated using the formula. After finding this one, D4 must be calculated. For that, we have to take the fourth column and fourth row of the previous table. That is, D3 table can be written as it is here. Then the remaining values can be calculated using the formula. That's it. So now D4 is the solution. This is what is the distance matrix of this given graph. And now this is what is the algorithm, Floyd's algorithm. Actually, the formula is implemented inside the nested for loop. The distance without any intermediate vertex is taken, and distance with intermediate vertex k between the vertex I and j is also taken, and both the values are compared. Minimum value is taken, that is stored in the element d of I comma j. This will be repeated. Okay, and so that the distance matrix will be calculated after completing all the for loops. The matrix or the table D will be containing the distance matrix. That will be the output of this algorithm, Floyd's algorithm. Now, the time complexity of this algorithm is theta of n cube, because the time consuming operation is addition that is available inside the 3 number of nested for loops. And this addition is going to be repeated for n cube number of times. So the time complexity or time efficiency of this algorithm is theta of n cube. Thank you, students.